Hello everybody, we are into the part 3 of the introduction to Protege in 10 points. In this lecture, we'll start with something very important which we call as property chain axiom. So in this axiom, what we can do, we can chain multiple properties together to define another property. Right? So let us take an example from the domain on which we are developing the ontology for, which is basically the book and the publisher domain. So there we have one relationship, that is co-authorship relationship, right? So we are trying to say that you have something called co-author, right? And how do you define this co-authorship relationship? Let's say you have one author A1 who is basically the author, or this particular A1 has authored the B1, and B1 is authored by B2, sorry, A2. Now in that case, you can say that these two are related via this co-author relationship, right? So we have a chain starting from this A, following this authored relation, and then hopping over this B1 and following the next relation which is authored by to come to A, right? So basically we are talking about the chain authored and then followed by that authored by, and this if two elements, in this case A1 and A2, if they are connected via this chain, then we say that A1 is a co-author, A1 is a co-author of A2, right? So basically we are trying to, so if we convert this into the OWL form, so it will be looking like this: authored by, which is basically a sub-property of co-author. So any two pair of individuals that are connected via this chain will be sharing this relationship co-author. So that is what we are trying to mean. So we can generalize this by saying something like this: say P1, P2, then Pn will be a sub-property of some another property, right? So let us try to model this in Protege, right? So we have this co-author, we have not really instantiated or defined it properly. Now here we are going to define it. So if you click on super property of chain, so author, then authored by, authored followed by authored by. And if you just say okay, then you say you have defined authored, then followed by authored by is a sub property of co-author, right? Now let us have some example like this. FSWT. FSWT has got has been authored by Coates, has been authored by Hitzler, has been authored by Rudolph, right? Now if we run the reasoner at this point of time, so the reasoner is running, then we try to see the properties of the authors. So for example, Hitzler. So let us go to Hitzler. Now you can see that we have inferred co-author. Hitler has got co-author Quads, co-author to be Rudolph, etc. Right. So this is what we can infer. Right. Now at the same time, you can define this co-author relationship to be one symmetric property. Right. Now if you define it to be symmetric property, then you can see the other way of inference you can also do. So I'm not doing it here. You can create one explicit co-authorship relationship between two authors and then try to see whether this the property of symmetricity holds or not. Now moving on to the next point, I think this is a very crucial point, which is something to do with cardinality restriction, right? So our 7th point is cardinality is about cardinality restriction. Right. First, we will try to model mean cardinality. Right. So first, we can define two types of cardinality. One is qualified and unqualified. Right. So let us try to define a concept that involves mean cardinality and as well as qualified cardinality. So let us define something like a collaborated book. So we have a concept called collaborated, right? Now, we say this is equivalent to book intersection. So there should be at least minimum 3 relation out of a subject and the object value it can take only author, right? And the corresponding unqualified version of this would be collaborated book equivalent to book intersection greater than equal to 3 just authored by. Right. Now let us try to first model this, right? And we'll play with this a little bit, right? So we have to have at least minimum 3 authors to be some book to be coming under this category, collaborated book, right? So we go to classes, create one new class which is collaborated book, right? And let us name it to be, okay, it's fine. So we'll just modify and try to make it equivalent to book, and it should be authored by, so authored by. So this is how we specify mean. We just say mean and then we should mention the cardinality 3 and the cardinality restriction class, which is in this case author, right? So let's try to put it under parenthesis so that we understand what really we mean. So we are done with this definition. Now our focus would be on the book FSWT, right? Now this FSWT, you can see that there are 3 individuals, Quates, Hitzler and Rudolph. So there is at least 3 authors for this particular book. So by the definition, it should belong to this collaborated book, right? So with this, let us try to run the reasoner. So if we synchronize the reasoner, and you can see that rightly it is coming under this collaborated book. So this FSWT is becoming a member of this collaborated book, right? Now there is something else to this. Let us go to Hitzler or Coates. Let us go to Hitzler, right? Now here we have mentioned that Hitzler is different individual from Coates and Rudolph. Let us try to remove this. Now if we remove this and then try to run the reasoner. So earlier we had for the FSWT belonging to collaborated book. That was what we inferred. Now if we try to synchronize it, now you see this is gone. So this is no longer a member of the particular collaborated book class, right? Now why is that? This is because of the very thing which we call as unique name assumption. So according to this unique name assumption, the individuals, they should be having unique name, and that is not followed by semantic web formalism, because semantic web uh, works in the domain of open world assumption, right? So in that domain or in that world, one individual can be having many names, right? So in that case, this unique name assumption is violated. So by default, as one particular individual can be having many names, if you don't say explicitly that two individuals or URIs are different, they will be treated as same. Now here we have removed this different individual assertion from this author, the Hitzler, right? So as we have removed this, now this Hitzler is being equated with, say, Coates, is being equated with Rudolph, and as it is being equated with the other authors, they are being collapsed into one author, right? One individual. And this, if we do so, this greater than equal to 3 is not being satisfied. So that's why you do not see this particular FSWT book to become under this collaborated book, though it has got 3 relations having this authored by coming out from FSWT. So to ensure that, what we should do, we should insert this or assert this unique, this different from or different with uh, definition. So we say Rudolph and Coates, they are different individual than Hitzler, and if we do that, the same thing will happen to Coates. So there we'll see that Rudolph and Hitzler is different with Coates, and for Rudolph it will be a kind of similar affair. Now at this point, again we move to the book FSWT, which was not under this collaborated book, and in this change scenario, if we synchronize the reasoner, we see that this particular FSW2 book is coming under this collaborated book category, right? Now let us try to demonstrate the case of collaborated book unqualified, right? So what we'll be doing, we'll be just changing this particular uh, expression. So in order to change, you just need to click on this round button, and there you just remove this author part, and it becomes unqualified definition, right? Now there is something else that is needed to be done. What is that? Now if you see this authored by, in authored by we have mentioned uh, or say authored, we have mentioned this domain and ranges, right? And if you do this, and as authored by is the inverse property of authored, the range of this authored by will be taken to be authored. Now automatically Hitzler or Coates or Rudolph, they will be classified under this author category. Now we are trying to do model or demonstrate the unqualified thing. So for that we will be removing these restrictions. this domain and range restrictions. So let us remove this and remove this. Now if we try to synchronize the reasoner, so we'll see that for say Hitzler, it is not coming under author. You don't see that it is coming under the type of author. But for Quates and Rudolph, they are under author category because they have been defined or defined to be under author category explicitly. So what is the scenario now? FSWT has been authored by Hitzler, Quates, and Rudolph, but out of them, only two are author. Other is, we don't know what is the kind of class that is associated with that particular person, right? Now I'll try to see whether with this change scenario, whether it will be categorized to collaborated book or not, right? So let us try to run the reasoner. So the reasoner is already running. So if we go to say book FSWT, it is there. So you see that this FSWT is coming under this collaborated book, right? So we have now demonstrated the unqualified cardinality restriction with respect to this mean cardinality. Now I want to demonstrate other things. So if we just change this to the original one, the definition of collaborated book. So let us keep it to be author, right? So earlier, this FSWT, when we did not change this object property domain or range of this author here, we had this collaborated book to contain this FSWT. Now let us try to see whether we are having the similar kind of situation or not. So FSWT was under collaborated book. Now we synchronize the reasoner. Now you see this is gone because of the very fact that now this cardinality restriction is qualified, right? So we need three authors to be there at the object position of the property authored by. But here what we can see that only two are there. So only Quates and Rudolph, they are coming under the author category, but Hitzler is not coming under author category. So that's why the restriction less than equal to 3 has authored by author is not satisfied. So in that case, FSWT will not be coming under collaborated book, right? Now let us get it back to collaborated book. So how we can do that? We just for author, we say the domain to be say author, and the range to be book. So if we do so, then we'll see, let us go to FSWT. Now in the earlier case, it was not coming under this collaborated book. Now if you synchronize the listener, you can see that this is coming back under this collaborated book, right? So we have demonstrated the mean cardinality, right? Now let us get to the other case, which is kind of, I think we'll be talking about max cardinality. So the second case that we'll be taking up is max cardinality. So here we'll take the definition of book with maximum 3 authors, right? So this is what we'll be defining. Book with maximum 3 author, right? So we define this to be equivalent to book and less than equal to 3 authored by author, right? Now let us try to define this and see what happens there, right? So let us define this class under thing. book with max 3 author, right? And make it to be equivalent to book and authored by max 3 author, right? So we have defined our class. Now what do we expect? So we are asking that the books that have at max 3 authors, right? Let us have a look at the books. So let us go to book. So FSWT is having 3, right? So in that sense, FSWT will be satisfying the condition, right? So it will be coming as our output, right? Now coming to say Great Expectations, it is authored by Charles Dickens. So it is only authored by one. So in that case, it will also be coming as our output, right? So let us take Oliver Twist. So it is also authored by Charles Dickens. Emperor's New Mind, it is, we do not have any author for this. So Etting Game, we do not have any data about this. So at least we have got some books which have got the values for authored by, right? And we know this FSWT, Great Expectation, or Oliver Twist, they should come as our output, right? Let us try to see whether we are having that kind of scenario or not, right? So we have defined this book with max 3 author, and then we try to run the listener. So we go to class, then synchronize the listener. So we should have expected this FSWT, Great Expectation, or Oliver Twist to be coming here, but we don't see anything here, right? So again, that is something to do with open world assumption. So open world assumption says that even though I have not said, so I have said that this FSWT book has 3 authors, but at certain point of time, you can say that this book has got another author. So in that case, the cardinality of that would be 4, and which is not really conforming to the case of max cardinality. And that happens to the case of Great Expectation as well as Oliver Twist also. So you can add, say, 3 more books to make them greater than 3, right? So in order to tackle this, we need to perform something like closure, right? So what we mean by this? So let us go to the scratch pad and let us try to visualize what we are trying to mean by this. So we are saying that a book P1 is having, say, author, I'm just writing A, to be A1, A2, and say A3, right? Now, the question is coming that if I add one more A4, which is, well, with open world assumption, which can be there, right? So this is following OWA principle. In that case, our cardinality for B with respect to this particular relation A would be 4, and this will not be satisfying. So what we'll do now, we'll say that this B, along with this description, we'll say that B1 has got authors to be only this A1, A1, A2, and A3. So it will be having author either from A1, author to be A1, A2, or A3, nothing more, right? So we are kind of closing the set of values that B1 can take. So we are closing this. So we are closing this set. We are not taking any kind of other elements out from outside this set, A1, A2, A3. And that is the set of authors for B1. So this is, if we assert this fact, this is called something like closure axiom. So you are closing the set of values that B can take as object, right? So let us try to do that and see what kind of effect we can have in our discussion. So let us go to individuals. Now for book FSWT, let us add another expression as type, that something. So it is belonging to this FSWT is belonging to a class which is an anonymous class expression that has something like this: has author, or sorry, authored by only. So whenever we say that this is the only value or all values that it can take, so that we represent with only, right? So only the set consisting of Itzler. So we are closing this set. Itzler, Oets, and then Rudolph. So this is the set we are restricting, right? And if we do that, and let us do it for, say, great expectations also. So we are saying that it is authored by only, say, Charles Dickens. And also, let us not do it for Oliver Twist. So you'll see the effect, right? So you have changed the ontology. Now let us try to uh, uh, mm, go to the class and select book with max 3 authors, and then try to run the reasoner. So after synchronizing the reasoner, so let us see what we get. We have added the closure axioms for FSWT and great expectations. So if you see in FSWT, we have added the closure axiom that says that it is authored by only Hitzler, Coates, and Rudolph, nothing, no one else, right? And also for great expectations, we have added the closure axiom like it is only authored by Charles Dickens. But for Oliver Twist, we have not really added this closure axiom. So that's why this FSWT and great expectations, they are coming as the instances of, or the inferred instances of a book with max 3 auth, but this Oliver Twist is not coming as the member of this book with max 3 auth, right? So you can see what kind of roles this open world assumption can play, and what are the kind of ways to circumvent that. So you are kind of forcing this system to behave like a closed world assumption, though we are in an open world assumption domain, right? Now with this, let us move to the all values from construct, right? So, so the third case of the cardinality restriction is the all values from, right? So all values from. I will not say this is cardinality restriction, but it has something to do with the elements that can be having in the object position, right? So to demonstrate this, let us try to define a class like academic publishers. Now this academic publisher is a class that is equivalent to the publisher class and intersection with, so all the books they published, so all the books they published, they should be all from the genre academic. So they should all be from the genre academic. So for all as genre academic, right? So this is what our definition of academic publisher is, right? Now, with this definition, let us move to Protege to our demonstration of this. So here, first we have to define academic publisher, which we have already defined. So basically, so let us remove this first. Let us do it step by step. So let us define academic publisher right? Now we'll be defining this later. So let us manipulate the data in a way. So this FSWT here, let us remove this closure axiom, and also for okay, let us okay, yeah. So for a publisher like CRC Press, let us also remove this closure axiom, right? So with this, let us go to the definition of academic publisher. So the academic publisher is equivalent to publisher and published only has genre only academic. So this is how we can represent the formula that we have written in the scratchpad, right? Now it is becoming to be the subclass of publisher because we have got the publisher intersection sum, right? Now coming to this, let us go to one publisher like say CRC Press. So we need to look for publishers. Publisher CRC Press. Now CRC Press published FSWT, right? Now the first part of the relation is there. Now we need to check this whether this FSWT is belonging to the academic genre, right? Now let us go to FSWT book. FSWT has got genre to be semantic web, and the semantic web, you know that it is belonging to the academic domain. So this is coming out to be good, right? Now let us look at other publishers. So okay, so let us have this publisher. Now by the intuition, by the logic that we have followed, that we have started with this CRC Press, right? Now the CRC Press has published FSWT, right? And also this FSWT is having the genre to be semantic web, right? So this is what we have, right? So let us have a look at another book. So for example, methods in algorithmic analysis. Now this methods in algorithmic analysis, it is published by CRC Press, right? And it has got genre to be algorithm, and algorithm is coming from the domain of academics, right? So to summarize, CRC Press has published two books. One is FSWT and methods in algorithmic analysis, right? And FSWT belongs to a semantic web domain, and methods in algorithmic analysis belongs to algorithmic domain, and both of them are from academic domain. So let us try to draw it in the scratchpad. That will make the thing more clear. So FSWT published. We should start I think from a little bit left. So FSWT published the CRC Press published FSWT. right? And it also published methods in algorithm analysis. I'm just writing methods in algorithm, right? Now this FSWT has genre to be uh, semantic web, and this methods in algorithm has got genre to be algo, and both of them finally they belong to the genre academic. So by that sense, CRC should be classified under the academic publisher. Right. Now let us move to Protege and see whether that is happening or not. Let us see whether we have modeled the scenario like that. So what we have for methods in analysis, it is published by CRC, so that is there. And this published by is inverse of published. So if we go to say CRC, start with CRC. CRC has published methods in analysis and published FSWT. So these are the two books it has published. Now FSWT has genre to be semantic web, right? And methods in algorithm analysis has got genre to be algorithm, right? And both of them belong to academic. So we have got the exact scenario that we have drawn there, right? Now with this, let us try to run the reasoner and see whether we have this CRC in our instance, to be the instance of academic publisher. We don't see that, right? And again, you see this uh, problem of open world assumption coming into picture. And in order to circumvent that, we need to impose the closure axiom to the respective places. So what are the kind of closure axioms, or where we should put the closure axiom? There are two for all constructs here, right? So at every place we need to impose the closure restriction or closure axiom. So the first thing we need to put a closure on has genre of the FSWT book and the methods in algorithm book, right? So let us do that. So let us restrict the genre of this particular book. So we say has genre to be only semantic web, right? Or we can do the other way. We can just say, okay, the individual semantic, right? Now let us do the same for methods in algorithm analysis. So what we'll be doing, we'll be adding here has genre only the algorithm, right? So you have closed the kind of value it can take, right? So it has got only one genre, which is algorithm, and FSWT has got only one genre, which is semantic web, right? Now we need to close the publisher, right? So go to CRC Press and say that this publisher publishes only these two books, right? So it publishes, so published only FSWT and methods in algorithm analysis, right? Now let us see what happens. So we have done all the closures. Let us try to go to academic publisher, synchronize the reasoner, and you can see that CRC Press is coming as an instance as expected, right? So this is how we can deal with this open interval assumption in case of all values from also, right? Now let us try to demonstrate the case of some values from, right? So the similar thing we will be doing with some values from. So the case that we are, the example that we are trying to put forward for some values from, so our next case is some values from, right? So here we define something like mixed domain publisher, right? So how do we define it? It will be publisher intersection. It should publish at least one book that has got at least one genre, say fiction, right? And also it published something that has genre to be, say, academic. So we can have a better definition than this, but let us have this definition in place, right? So what we are trying to really model, P as genre, the again has genre. It is your, so you have sorry, P publishes a book, publishes B1 and P publishes B2, right? And this B1 has genre fiction, and this B2 has genre, say, academic, right? So this is one case. The other case is, say, let us have this mixed domain publisher to be equivalent to publisher and, say, has genre, sorry, has published or published, and it has published, and again it will be having as has genre to be the intersection of, so okay, has genre fiction and intersection of has genre academic. So this is a kind of revised definition. What would be the visual representation of this? So P, so it publishes a book P1, right? And it has genre to be G1, which is basically fiction, and it has got genre to be G2, which is academic. So these are the two scenarios. Let us try to see the demonstration of this, right? So let us create this class, a mixed academic mixed domain publisher, mixed domain publisher, right? So we have defined this under academic publisher. We should put it under, say, thing, right? So this is equivalent to, let us first write the first expression. So publisher and uh, published, then sum, right? We have existential quantifier sum to be has genre and some fiction, right? And we have kind of same thing. Let us copy this part and put it here, right? So if we do so, and I guess we are missing with one parenthesis. Okay, yeah, we have to put one parenthesis here and one parenthesis here. Now here, so it should not be fiction, it should be academic, right? Now let us see what are the individuals that we have. So this should be publisher, of course. CRC Press has published FSWT and methods in algorithm analysis. Both of them, they belong to academic domain that we have seen earlier. Now check Atlantic. Now Atlantic has published Great Expectations and Linear Algebra. Now these Great Expectations, if we see, this Great Expectation is belonging to the mystery domain or mystery genre, which is coming under fiction, right? And linear algebra belongs to the maths domain and which belongs to academic. So this is a case where we have this publisher, which is basically Atlantic, which has published two books. So one is Great Expectations, other is Linear Algebra, and Great Expectation belong to fiction domain and Linear Algebra belong to your academic domain. Now with this, we should expect this Atlantic should belong to mixed domain publisher, right? So let us select mixed domain publisher and then try to synchronize the listener. And you can see that Atlantic is coming under this mixed domain publisher, right? Now let us come with the different alternate representation, which we have discussed in the second part, right? So here we have got this published. Up till this is fine, and it has got some and has genre to be fiction, and this will be having another and this published will be gone, this and will be removing this part. So it has published some, so the sum will be over this, and we are taking the intersection of this class and this class, we should close with another bracket. So okay, another, so we need to have another parenthesis. So then we are really modeled the thing that we have discussed in the second part, right? Now here let us see what kind of output we can get. I see that Atlantic is no longer the kind of instance of this mixed domain publisher, and that is really justified because it has published two books, and these two books are one from fiction, the other from academic, but it has not published a book which is both from genre fiction or academic. That's why this Atlantic has been removed from this mixed domain publisher, right? So I guess let us stop here at this point, and we'll be having another part of this uh, introduction to Protege. There we'll be talking about some other features to be demonstrated. Thank you very much.